Okay, dear students, so now today's lab experiment will be on experiment number 7. Okay, formation of this is the last MATLAB program I'm discussing here. Previous already have discussed now all those program. So now this is the formation of Jacobian matrix in polar coordinates. Okay, Jacobian, the term word comes in Newton-Raphson method, is it? And forming that matrix itself, it will take time because individual matrix, that is HNML or J1, J2, J3, J4 matrix, it will be there. So this is the matrix as what we are forming, and individual matrix diagonal off diagonal values has to be formed. Okay, H diagonal off diagonal, N or diagonal off diagonal, M diagonal, L, and individual partial derivative has to be done. Okay, it itself, it will take more time in Newton-Raphson method. Okay, and you can compare this with respect to other methods also, Gauss-Seidel law for decouple, fast decouple, like that. Comparison will be there in theory that you can go through. Okay, and these are the derivation as what we have done in Newton-Raphson methods and all. I'm going to discuss now here how to form this Jacobian matrix, and we are forming this Jacobian not exceeding 4 buses and only for PQ buses, not PV, and we are forming in polar coordinates. Actually we have to do using a standard package, but I am doing in MATLAB here. Okay, and same thing we can doing we'll do this in software package also by using another problem. Okay, let us do this in MATLAB. This is actually in software package you have to do, but I am doing in MATLAB, so all you have to do in MATLAB only, this one. Okay, so now whatever, see, so just have a look here. So this is the problem what they have specified here. Okay, so data they have specified here, and the connection what they are given. So see, so now this is the connection in between 1 to 2, 1 to 3, 2 to 3, and impedance value how converted into admittance individual. And first bus is slack bus, second PQ, third PQ, because for PQ we are doing not PV, 3 bus system. For PQ buses, P and Q is known, V and delta is unknown. Okay, and PQ bus another, P and Q is known, P and delta is unknown. Okay, so now with this, let us go for this and already admittance value is there. So 1 to 2, 1 to 3, 2 to 3, and whatever admittance value is there, you can put it on this in this diagram itself. See, 1 to 2 value is how much? J.1. Just I'll substitute here, this is minus 10J, minus 10I. 1 to 2, and 1 to 3, if you see, how much here? Minus 5I. See, if you form this first node, 1 1 is 1 to 2, 1 to 3, 1 to 2, 1 to 3, add 1 to 2, 1 to 3, minus 10I, minus 5I means minus 15I. Only one I'll tell you, remaining you have to do. This is minus 15I. Is it off diagonal? Minus of minus plus 10I. So Y bus you have to form. It will ask number of elements excluding bus will be 2 will be there, and first V0 voltage all 1 1 1, all voltage you have to substitute 1 1 1. Okay, start with P count. So because already first bus is slack bus, don't take that. So start with 2 issue n, number of buses. HNML or HNJL you have to take all PP. All first I'll initialize this matrix 0. Let us Q you take. Starts with 1 issue n. Okay. If P is not equals to Q. So now I told each individual HNML, all those matrix, the diagonal off diagonal values you have to form. H of PP means diagonal. H of PQ means off diagonal. N of PP means diagonal. N of PQ means off diagonal. J of PP means diagonal. J of PQ means off diagonal. L of PP means diagonal, off diagonal. Then how to form this? What you have to remember while doing this, whatever line you will write, same thing it is there. Next slight change will be there. CH PP diagonal plus voltage, absolute of voltage P, voltage Q, and admittance and its angle. Voltage of VP, voltage of Q, V naught of Q into YPQ, sine of angle voltage, sine of angle Q minus P plus angle Y of PQ. Okay. What it is there, I repeat, H of PP, absolute of voltage of P, voltage of Q, admittance, sine of angle of voltage and its angle of admittance. Okay. Now H of PQ you take, because off diagonal what you will be getting, minus of that you will get. That's why minus absolute V naught P. Remove this H of PP, only remaining minus you have to write, remaining same only. V naught P, V naught Q, and out of this HNML, some equation having positive and negative value is there. So H of PQ will be minus because of diagonal value. H of PP is not there. Remaining everything is there. Only this you have to delete in second one. Remaining same. Third one, N of PP, and instead of H now you write N, PP, voltage of Q, voltage of, and here voltage of P is not there here. Only voltage of Q you have to write. Okay. N of PP, that is the change, slight change. Y of PQ, cos of angle of voltage of Q, voltage of P, and admittance. And N of PQ take, again N of PP don't write, keep it positive only. For N we will be getting positive. Same thing. Okay. Your same thing you have to write v naught of p y of pq cos of angle of this same thing. Okay, now j of pp you write voltage of p q admittance and cos here sine and here cos we are getting n and j cos and h and l sine we are getting. Okay, l you take l of pp minus we are getting here slight change voltage of q admittance of yq sine of angle. Okay, and L of PQ will be minus you have to write voltage of P absolute of this, and only this L of PP you have to remove. So below you have to take slight change while writing. You have to careful. You have to write. Once you got, if both are equal, P and Q will be equal, then N and L it will display. Same N and L whatever is there for diagonal it will display. Same thing you have to copy paste here. And because for if and for 2 for 1 if, so 3 and we are getting, so HNML we are getting 2:3 2:3 and HNML matrix and Jacobian HNML it has to display. Okay, so see, this is 2 3 and values they have given here, 2 3 values 2 to 3. So this is number of buses it will ask 3 and Jacobian matrix it will display. So HNML values it is displaying. Okay, this is 2 to 3. What does it indicates here? 2 to 3 nothing but if you see this matrix, so 2 to 3 in the sense, so second row third, just like they have given here 2 to 3 2 to 3 means second row third column, second row third column. See second row, just wait here. Okay, so now if you see this matrix 2:3 2:3, this is what 2:3, this is row side, this is column side if you take it. So now check it 2 to 3, 2 and 3, just draw a line on this 2 3, again 2 3, again 2 3. If you cut it, 2 junction line where if you select middle you are getting like this. Okay, what I am telling 2 to 3 2 to 3. Row means second row, third row, cut it, and second column, third column if you cut it, junction we are getting in this. So we are getting 2 cross 2 matrix. So HNML, HNML or HLJL. Okay, so this is the Jacobian matrix what we got. So 2:3 means second row, third row, second column, third column, just cut it, drag it, and wherever junction 2 lines it will cross, that value we have to take. Okay, so that is the values we are getting. Okay, HNJL form. Okay, so this is all about experiment number 7. So till now what and all experiments we have done, just I'll recall. Okay, these are all experiments are there what I discussed previous. Experiment 1, ABCD parameters, power angle diagram. Second, third one, swing and equal area already I have discussed. Fourth one, Y bus by inspection method and singular transformation, Z bus building. Fifth one, sixth one just now I discussed. And seventh one by Jacobian matrix. Eighth and 10th we are doing on software package. And ninth also we have discussed on fault calculation, LLLG and DLG. These are all whatever till now I discussed MATLAB programs. Okay, so now except this Jacobian we have to do in software package, but we have doing in MATLAB only. So now in software package we are doing 8th experiment and 10th experiment. Okay, so we'll discuss in next class. Okay.